I'm Quinn. I'm going to be hosting the next couple talks on this track. For this next speaker, we have someone with over 15 years experience in embedded development who's since made a complete pivot to web development. That seems to be a common pattern in his life, with him having an existential crisis every couple years, whether that's moving across the world to the UK from Brazil or just taking up surfing on a whim. Let's give it up for Thiago.
Okay, guys. Thanks for having me. Thanks, Quinn, for the presentation. So first, I would like to thank Airline Solutions for sponsoring this talk. So it's a global company with deep expertise across many industries like telecom, blockchain, e-commerce. So they go-to experts if you need like expertise for being applications. So this is the place to be. Okay, for the agenda today, like I divided in two segments. Like the first one, we'll talk about abstractions and the challenge that they can introduce to your solution. Also, I will share a little bit about my journey with Elixir deployments, and finally, I will present the alternative through DeployEx. So let me tell a story. Let's rewind a bit around 2010. So this is the kind of problem the team I was working on was trying to solve. So the picture shows two cities being connected via fiber optics with protection in place one of the paths fails. This is a common scenario in telecommunications. It's known by SNC connections with protection scheme. So at the time, we were developing transponders that are these equipments that the main idea is to convert signals, electrical signals and optical signals and vice versa. So the path in red shows the working path where the data is being transmitted, and the yellow path shows where it's an alternative path for protection in case one fails. The configuration is simple. So the transponder B is monitoring the signal in the working path. And if something fails, it has to commute to the protection path. And there are many restrictions in this scenario that the transponder has to follow. Many of them are described in standard documents. But there is one in particular that is very important. The time between the fail detection and the switch to the protection path cannot exceed 50 milliseconds. The system requires a real-time failover. We were able to achieve this real-time performance using the first generation of transponders, which were developed using microcontrollers. In a nutshell, microcontrollers are specialized chips that integrate CPU, memory, I/O interface, and more. So with low cost and minimal space in the board, they enable highly efficient control system. I brought here an example of this kind of microcontroller, this MCF52259. So you have 80 megahertz of CPU, 512K of flash memory, some low-speed communication like UART, I2C, etc. Working with microcontrollers puts the developer in sync with the hardware. It leverages the hardware interrupts to handle real-time tasks without any operation system. It executes tasks in a deterministic way, so you can see every task is like expected to be the next. So, and sometimes you have a hardware interrupt that you program the system to follow this path. However, this approach comes with many limitations in programming. Developer must be conscious of issues like race conditions, deadlocks, and much more. Despite these challenges, this kind of equipment and solution was capable of achieving the commutation time of 50 milliseconds. So what's the issue? The issue was the system that we were using had many limitations, starting with serial and very low speed communication between the main board and the other slots. So there were also significant constraints on program size, memory, data storage, upgrades, and more. There was a clear need to modernize the first generation, adding features like Ethernet support, file system control, improved CPU speed, more memory, etc. So we are talking about 2010. The solution at the time was to start to use embedded Linux in a system of a module, popularly called SOM. So the cost of this CPU were dropping, making them affordable. With embedded Linux, we gain access to a wide range of tools, free tools like Ethernet, encryption. You can run different language, SSL, files, etc. So you can do a lot of things with this SOM. That's the configuration of one of the zones that we were using, like AM3517. That's 600 megahertz of CPU, 512 megabytes of flash memory, and 256 of RAM. And we have Bluetooth, wireless Ethernet, everything. So much more high-speed communications. However, it's important to note, now that you are using an operational system, you no longer have a control of the scheduler. So the OS will dictate the task execution, and you can't predict when a task will be executed, even if you map a hardware interrupt. The solution for the new system would involve boards using some communicating using Ethernet, and also with the slots, we could have like file transfers and upgrades using this, this kind of connectivity. And also they would be distributed connected, which was a nightmare at the time without Erlang. We were trying to use C++. So the project took about a year to reach a point where we could do some testing on stage. The overall results were quite positive. But with the new CPU handling controller, tasks were much faster. Now let's take a look at the commutation time. We tried 10 commutation time in a row, so we got all of them less than 50 milliseconds. But when we went through 100 failures in a row, one was over 50 milliseconds. So this was unacceptable. And that's when the panic started in the people. Like after a year, we were like, oh, we have a much better equipment. Why we are not achieving these times? So let's see in the options. And the options here that I'm talking about is just software options, because you can do something in the hardware. But the software options was like, let's do a heavy debug. Like maybe there is something lost, a deadlock, a concurrency problem, something. Let's do a deep debug. We did it, but nothing came out of it. So the other option was, well, we can change task priorities. The Linux give us this ability. But again, we changed it, we did some tests, and again, we were having some failures as well. Why not check performance? So we have the code, it's many, many lines, let's check again. And again, no success. And we also have the option for the kernel flags. So you can go to the kernel before compilation and start to change some of the flags to, for optimization and everything else. So, however, this also not, we got a lot of improvements from this task, but again, we could see some errors in some of the bigger roles, like with more than 100 failures. We put a lot of effort in to find a solution with the Linux, but nothing worked. No matter what we made changes, the commutation time was always above the minimum required, some even exceeding 100 milliseconds. It became inevitable. We have to accept the fact that Linux is not real time. So it's difficult to accept at that time, since that you are getting a machine that is 10 or 12 times faster than a microcontroller and have ability to do a lot of things. Well, we can do something, but in order to do something, we have to go deep in the kernel. So I just bring here a comparison between the two systems. Like you have a microcontroller and the COS, and you have like the zone on the right. So you could see like 10, 12, much more, more capacity and ability to do stuff. But again, we couldn't do this with this system. But it is not possible without going inside the kernel and understanding everything that we were trying to avoid. We brought Linux embedded system to get a lot of things for free, trying to avoid the OS, but now, in order to fix this in software, we had to go deep in the kernel. So, and to have an idea, the kernel was able to have a real-time task only in 2024. We are talking about last year. So it's 14 years later when we were doing this kind of stuff. And that's just the starting point. So just because you can have a real-time task, you still have to do a lot of work in the system that you are working to really attend these real-time requests. So what I want you to take from this initial part is like the lack of control over the scheduler that you have when you are running your application and the abstractions you put. Like when you brought Linux, you brought a lot of abstractions. You got a lot for free, but you also put a lot of abstraction on that. So I will not discuss the solution for this problem because it's not the matter of this, but we can talk this offline. But let's go to the next talk, the next part of the talk. Like, let's move from 2010 and go to 2020, like 5 years ago. So in this journey, I went from C, C++, safety, Erlang, and finally Elixir. So I will just, let's say that it's me playing around my first Elixir application in 2020. So I did the basics. So I created an application using the mixed Phoenix New because it was a web server. So I built some endpoints and designed a few UI pages. Now I want to deploy it using mixed release. That's what I was doing in the embedded system. So it's important to know that deploying is part of the learning process. So I could stop here with just the web server, but I want to see this for you, how it is to get this application and put it in the real world. So that's this painful is what we can we will really learn from this process. Okay, once the release is packaged, I just need to get a server. In this case, I put the AWS, so to run the application. As I show, I created this script, small script, that at that time was using distillery. So I was able to run the application and do the migration and also do hot upgrades. So this was 2020 with distillery. This was enough for my personal project. I was able to put this in the server and it was running all fine. So let's move to the first professional project, like when a company was already running and hired the services. It's like, okay, I will take care of this project for you. So how you're going to do how are you doing your deployments? So the process of creating a release in that company was using a Docker file. So in other words, the application was containerized. This led me to the simple question, why? Why is a container? So after a mixed release provides like your release to run in the host, why a container? You just need to install and run. But let's keep going where this is going with this container. So, and the deployment was using Ansible template. So there were so many files that I couldn't put here, like, so you can't see, because it's impossible. These files were managed by another application called, you know about, Kubernetes. So upon digging deeper in the files, I realized that I could deploy everything locally. So I could get my computer and deploy Redis, databases, secrets, everything locally. So that was like, oof, maybe this container is just for running locally. So you could test things not in production. So, but I was wrong. So the same files that were there were getting this and put in the production. So I did a step back, and let's check the details of how is the deployment when you have Kubernetes. So in this is a typical configuration. You have like 4 applications being managed by Kubernetes using templates. And you can think of this image of our system, but let's add some details here. Like, so you have Reds, RDS, that's the DB, the secrets, and your Elixir app. So if you look with a deep eye, you will see that your application is not the application per se. It's an emulation. So in order to run a container, you need something to emulate that container in the system. So you need something like the Docker, even the Docker or Kubernetes, doesn't matter. They need an emulation to run that container. So it introduces a lot of things like delays, resource overhead, potential complexity because you have to imagine that for every port that Kubernetes is handling, the container has to have the same. So, and it's not just the inputs, but all the inputs and outputs are going through the emulation. So there is no path directly to your application. It has to pass through the container. So remember we talked about the scheduler previously, right? When we run the bean, so and the bean is running directly on the host, so you have this CPU scheduler that will allocate the slots. So one of these slots will go to the bean scheduler. Remember that bean is a VM, so it's running many things already, like not just your process, but all the other things that it has to run to be alive. So, And when you go and put a container in the middle, that's what happens. So now the CPU scheduler will give amount of processing for the container tasks. And the container task will divide this and give you to your VM. So you see a lot of these indirections for the CPU scheduler. And what about the other apps? So we are talking about your Elixir app. So have you ever thought about how AWS provides you RADs, RDS, or DB, or the secrets? Are they containers? So I asked ChatGPT for that, like, just a short answer, are these services containerized? And he just said, not. No, they are not containerized. So they are not running by containers, which makes a lot of sense for me, but I would like to ask ChatGPT. So since these services are not containers, you should ask yourself, if the cloud provider isn't offering containers by default for the service you are using, and you are a client of theirs, why are you providing containers for your own clients? So you are the only one using containers in this scenario. So you should think about it, like, are you providing the best solution for your client, and are you extracting the maximum value from the machines that you are paying for? So that's a good thing that you should think about. Okay, let's talk about another thing, network topology. So while Kubernetes excels at orchestrating containerized applications and scale microservices, it introduces a challenge for applications like Elixir that rely heavily on Erlang distribution capabilities, like via Erlang node-to-node communications. For features like distribution, state sharing, and fault tolerance. In order for the applications to connect, we need a library that facilitates this network discovery. While libcluster is a powerful and used tool for this purpose, it raises another important question. Why do you need to discover the nodes in the first place? Like, ideally, your application topology should be something you have full knowledge of. By introducing something like an automatic discovery, you add another layer of complexity, like how do you handle where the instance is unavailable or not found? So you don't know, maybe it's there or it's not there. So that's something that you should ask yourself before adding the libcluster to your system. So how is your network topology? Also, talking about hot code reload. Kubernetes was designed to short-lived stateless applications that automatically restart in the event of a failure. But in contrast, Erlang applications are built for long-running process with the ability to handle hot code reloading and maintain states across restarts without losing uptime. If your solution relies on stateless containers, you won't be able to use hot code reloading. So you just like using Kubernetes is just to say you don't have hot code reloading. So think about it. You have a stateless application most of the time. So you don't have a Jane server that has a state. So why you're not hot upgrading and never restarting your system? Okay, so this was my experience with that project. What about other projects in industry? Like, because I went through many industries. Maybe they were using different approach. So, and the next one was container. Different way of writing was a container. Another different container, container, container. So it seems to me that a containerized application is some kind of a recurrent pattern in this industry. So, okay, so before we move, so I can start to talk a little about DeployEx. I want to emphasize a key point. Try to keep in mind that the best way to extract the things that, or the resource from the bin is to run directly on the host. But you don't need to do this via DeployEx. So you can do this via systemd, you can use Jenkins, you can use any tool. So DeployEx is just an alternative. So I always look at to Kubernetes when I was deploying applications and say, whoa, would not be nice if Kubernetes was an Elixir application? So they could just send information via OTP. So in get and collect, it would be even simpler than that. You don't necessarily need to use DeployEx. It's just, as I want to say, an alternative. So let's look how DeployEx is working. So, and let's start with saying like DeployEx utilizes one library called exec. It's an Erlang library that allows you to spawn process in the OS and monitors it. So it serves like an orchestration. Like I can spawn 3 apps using this library. They are in another process, but I can communicate with them like using system signals, so I can get when the system crashes, which sounds pretty much like a supervisor if you think about it. So that's how it is spawning the applications. And it knows how many applications it has to spawn because you configured this before starting. And in case of a crash, it can just restart your application. Additionally, DeployEx is responsible to connect them via OTP. So you spawn the applications, and you know all the ways to find and to connect the OTP. So in the application, the first application is running, I should be able to connect to that via OTP and extract information if I need. So now I have 2 channels between DeployEx and the application. So the first is via our exec, that is the library, and the other one is via OTP itself. Like I can do health checks if I want. But I can do more. So if they are connected via OTP, we gain access to a full range of capabilities, including commands, monitoring functions, supervision, statistic, all available at no cost because OTP is there for all of these applications. So once that you are connected, you can extract this and start to monitor this information. So, well, OK, we talk about how it handles the application. Let's see how we do a deployment. Like, what is the steps that we are expecting from a deployment with DeployEx? So the first part, in this image, I am showing the Nginx. That is just for reverse proxy. Let's think about that we are in an EC2. DeployEx is running and monitoring that application. The first step here, you create the mix release. Simple as that. So you don't need anything else. So just mix release. You get a package. You get this package. And you put this in a storage, like a bucket. Like in this case, it's a S3. So you get this release. And you put that in that place that DeployEx is monitoring. But also, you have to put some metadata, like the current version, and also some information for migration, because DeployEx has to run some migration. If your application is connecting or using DBs, so you probably will need this migration. And as a consequence, like DeployEx is monitoring this bucket, so just check the current version and the current version that's being deployed and the current one that is being monitored. So if they are different, they just trigger the update. So the update can be 2 types. So the ones that I call full deployment, that's like I shut down the application and I spawn a new one. But the second one is the hot upgrade. So DeployEx can do hot upgrades in your application. And that's one of the things that I wanted to restore since 2010. I was looking for Distillery, and Distillery was merged. A lot of functionalities was merged in the Elixir, and hot upgrades was not. So I want to restore this. So ideally, your application has to use a library called a Jellyfish, and this Jellyfish will create the app of files. So we will not use the library to create relup files. That's the file that will dictate how you're going to hot upgrade. So ideally, you have just the API files, and the API files will be in the mix release. So DeployEx will look to the release and see, well, you have an API files. Let's check the versions. If the previous and the new one, they match with the API. If they match, I can create on the fly the relup file and update the application. So simple as that. OK, that's a look on the dashboard. So DeployEx is using the live view. So I'm not very good in UI, but I think that's will summarize everything. So in this case, you have DeployEx, because remember, DeployEx is an Elixir application, and I still want to monitor that. So, and the 3 below are application that is being monitored. So you can see that you have the instance name, you have the OTP nodes that are connected or not. So you can see in DeployEx, that's the MTLS, that they are connected using mutual TLS. So this is supported, and they are talking with encrypted data between the OTP. You also have some buttons that give you some access, because one of the things that you want when you are deploying and debugging is facilities. Like you can, I want to get the IX terminal, so what can I do? You can just click in one of these buttons, like in this case, this one, like that's a shell, so, and you have the IX connected with you. Because when you have OTP properly configured with encryption and everything, so connected to IX is a little bit a trick, because they will request you the cookie, they will request all the things that, the encryption, the TLS, the certificates, so it does everything for you. You just click, and you have the terminal here. So, and it works, DeployEx works with Glean and Erlang as well. So for Glean and Erlang, this will be the Earl terminal, not the IX. Okay, also remember, you are connected, so I have access to the host because I'm running the host, so DeployEx can go and see, where are you putting the logs? Oh, you're putting the logs here because I told you to put. So I can get the logs and put the nice dashboard like this. So you have like multiple applications and the logs. And one thing that I want important to say is like, for now, DeployEx is not a replacement for all the things that you have in AWS. You still have to put your logs there because it's not keeping, if your IC2 goes over, so it goes your information. So I'm not working in this now, but it's an alternative for quick access. So you see the logs here without going to AWS. So that would be a benefit. So you don't need a user in AWS to get the logs. Again, remember you are connected. You can check the traces. So you can check in every application what are the modules that are running there, what are the functions, and I can just trace any functions that I want. It's important to know that I put messages and timeouts here because once that you start this tracing, a lot of memory is consumed. So you have to be careful with that. So I put like a limitation. So you have just 30 seconds or 3 messages because you don't want to leave this running. So otherwise your application will shut down. This is an example of a function being traced. So it's just a num map. And so you can see the instance too was being called. And you can see like the return. So that's pretty handy when you are debugging. So you don't need to put a log. You just trace the function. And it doesn't stop here. So we offer an interface that's very similar to the observer. So you can combine the applications, and all the apps that are running in the application. So if I want to see, for example, the kernel on the first application, I can see this like this tree. That's pretty much what you have in the observer. So, but now you are in runtime. So you can get this and check like the red square is like a supervisor. So if you click, you expand even more, and you get so you see all the relationship with all the apps here. You can combine them if you want. So, and you can also inspect the function. So if you just hover the mouse, you can see that you get the information for the process, like the ID, the register name, the status. So you can see like the state itself, like it's printing for you if you want to see the links. Pretty much what you see in your observer you are seeing here. Okay, also I added this host terminal. Like it's just a terminal that will, once the DeployEx is running on that machine on EC2, so sometimes it would be nice to get a terminal from there. You can go via AWS, so you can get that SSH and connect to that, but you could pretty much came here, click, and get where the application is being deployed. So you are under this user that's called DeployEx. So these are the current features, but there are more like coming, like live metrics and telemetry. So if I am running OTP, I can start to collect the metrics from the CPU, from the VM, and start to put in a graph, like how is your system is running. But also, I just showed you a process, and I could monitor that process as well. Monitor its memory, so that's pretty powerful. Okay, so once the distribution is active, I want to say like the sky is the limit, because you have an application that on the top of all your nodes that are connected via OTP. So everything that they release that is related with OTP, I can use this one. So, and I am concluding this presentation by sharing a valuable piece of advice that I received from Joe Armstrong in his book. So I couldn't meet in person with him, but it was my first book. So it was amazing reading this, and it was a lot of good advice over there. So, and in the book, he states like, you have to learn to walk before you can run. And how to write sequential programs before you can write concurrent programs. So I couldn't agree more. Like, our learning journey is a series of phases, starting by simple steps and moving to complex one. And here is my take on it. You have learned how to walk with containers. It is time to run without them. Thank you.
Thank you so much, Thiago. We have just a couple minutes left for questions. To start, we have one from the audience. Michael asks, is Electric deployed inside a Phoenix app, or is it a separate server?
Sorry, say again?
Is Electric deployed inside a Phoenix app or as a separate server?
It's a separate server. Like the exec library, when it's spawning another application, it's using the OS system process. So it is not in the same process. They are completely separate. The only thing is that this library allows you to monitor via user signals. So if that process crashes, you will be able to receive a signal like, well, this application is crashed. So you can do whatever you want. You can restart, you can stop. So, but they are completely different. So of course, if a DeployEx crash, all of the monitors one will crash. That's how it is supposed to be a supervisor. So this is supervisor supervising this one. So if it crashes, everyone will crash. So that has to be pretty stable.
Awesome, thank you. Any other questions?
You had a slide and you mentioned libcluster. And I'm just curious how, if at all, DeployEx handles orchestrating connecting disparate nodes.
Yeah, well, first libcluster tries to use the network, like to achieve the point where, well, that's the name of my application. So I try to netadmin connect to that name. So what you do is, since the DeployEx is spawning the applications, so I can prepare the system like your name will be, as you saw, like my app, my Phoenix app 1, my Phoenix app 2. And you are going to use these certificates and give them, that's the certificate. So once that application is spawned, I know everything that I should about your application, and I can just do a netadmin connect to that name. If you are not there, I can do a couple of things. I can like shut down you because you should be replying, or I can restart. So you put all this information inside DeployEx. DeployEx is the orchestrator, so it should know where you are, which IP address you are using, if you are in the same host. The only thing that is not fully testable in DeployEx is if you have two nodes completely separate by, for example, imagine that one is in AWS and the other is in the GCP, for example. So maybe you can connect then, but you will need another strategy. So because it will be more complex, you need a tunnel, like encryption and everything else. So that's another thing for the future.
Thank you.
We have one more question asking how DeployEx can be installed.
Yeah, so for now, I created in DeployEx a series of Terraform files. So ideally, you get these Terraform files and they are ready for GCP and AWS. So you just run this. This will create the EC2 and also will put the infrastructure for DeployEx, which is being installed by systemd. So if you're not familiar, systemd is a system that runs in the Linux that is monitoring applications, and every time that the system starts, it checks. It is starting? No. So I start again. It crashed. It's like a supervisor for the Linux. So that would be probably how you would install your application in a system. So what I did is I put this in DeployEx, and I use DeployEx to manage the application because I am interested in this to know about the topology of the network. So that would be.
Cool. Thank you so much, Thiago.
Yeah, cheers. Okay. Anything else? Thank you, guys.